Right, so this lesson's on non-square matrices. So in recent lessons we looked at Hungarian algorithms. What we noticed with Hungarian algorithms is they were always square matrices. Okay, and that's what you need for Hungarian algorithms. In this exercise here we have a non-square matrix. So when we have a non-square matrix, we have to employ a technique where we put what we call a dummy link of zeros, or dummy line of zeros. So a dummy line of zeros, they can either be a column or a row of zeros. Okay, so what they do is they make up the space, they make up the missing column or row. Okay, so for instance, if we look at this example here, we've got 4 rows but only 3 columns. So we'd have to put in a dummy column of zeros to make it a 4x4 matrix.
Yeah.
Okay. What we're going to be doing today is we're going to be using this example here on what we do when we come with using non-square matrices and how we calculate our answer. It's basically one extra step above what we did with minimum and maximums. Okay. So in this case here, we want to allocate the maximum. So allocate the teacher with the maximum or the highest teacher experience. In years. So if I'm allocating the highest, am I allocating the maximum or minimum?
Maximum.
Maximum, okay? So remember when we looked at maximums, and we'll do this one over here, so we'll rewrite it, 9140. When we do our maximums, who can remember the first step we have to do? Well, the first step is we have to take the highest number in the matrix and subtract it away from and subtract all the other numbers away from it.
Yeah.
Okay? So the first step we do here is we're going to subtract all numbers. What are we going to subtract it away from?
9.
Yeah, from 9. So let's rewrite that over here. So we have 0, 2, 6, 8, 3, 2, 5, 4, 9, 9, 6, and 0. So now we've got our part of our first Hungarian algorithm prepared matrix. This is where we put in our dummy row or dummy column of zeros. Okay, so here we're going to put a dummy column of zeros. And the reason why we're doing that here is because, well, we've got 4 rows, but we've only got 3 columns. So this here gives us a dummy link, so it's just saying this here is just to fill in the space and make it 4x4. Okay? What that means here is, up the top here, it means there's no subject. So ultimately what's going to happen is that one of these teachers, Mr. B, Mrs. N, Mr. T, or Miss W, is not going to be teaching one of these subjects. They're going to miss out. Okay? Who remembers what we call this when we're going to start from our first point when we minus the rows? This here is called the Hungarian prepared matrix. Okay? So the first step we do when we do our Hungarian prepared matrix is we're going to subtract from the smallest number from each row. Is there any use doing it in this one? Is there any use subtracting the smallest number from each row in this matrix? No. Why is that? Because the smallest number is 0 anyway. So if I minus 0, I'm just going to get the same numbers anyway. So we can skip that step and come straight down to the next step, which is let's subtract the smallest number from each column. So we're basically now doing what we're doing with Hungarian algorithms. Step 1, smallest number from each row. Step 2, smallest number from each column. So down here, we end up with the smallest number is 0, the smallest number here is 2, 0, and 0. Yep. Let's now apply that. So we have 0, 8, 5, 9, 0, 1, 2, 4, 6, 2, 9, 0, and 0, 0, 0, and 0. Our next step here is, now we've got rid of all our zeros, we can now do our lines. How many lines do I need to be able to make sure I can start solving? What's the minimum number of lines I need?
3.
Not 3?
4.
4, because I'm going to look. So let's see if I can get 4 through here. 1, 2, 3.
Oh,
Not enough.
no.
So I can't force it. Why can't I go 1, 2, 3, and 4?
Just no zeros there.
Well, because it's the minimum number of lines I need. Okay, not trying to make it 4. So in this case, I now have to take this 1, and what am I going to do with the 1? Subtract it all the way from there, all uncrossed numbers.
Yeah.
Okay, so if we then come down to here, the 0, the 0, the 6, and we usually add 1 to this.
Yeah.
Okay? This here becomes 7, 0, 1, 0, 4, 1, 8, 0, 9, 4, 0, and we'll put the 1 there anyway. It doesn't really matter if you do increase this or not, because it's not going to make much difference. Let's redo the lines we did before. We could go 1, we could go 2, and we could go 3. I now need that 4th line. Because I've done the same things I did here before, and I got rid of all the zeros, but now I need to put that 4th line. Now you could do vertical or horizontal, it doesn't matter. Okay, so let's go vertical. Because we've got 2 horizontal, 2, okay, and now we've got 2 vertical. What's our next step we need to do here? Allocate our zeros. Okay? So remember, we're allocating unique zeros. So this one here is unique. Why is it unique?
Because it was the highest?
It's the only 0 that's represented in that row.
Yeah.
Okay, so it's only in that column. So it's only, so that means this one here can't be used anymore.
Yep.
That makes this one here unique for this column.
Yep.
And for this row. So now I can cross that one out.
Yep.
This one here is unique for that row and that column. And this one here is unique for that column and that row.
How is it unique for that column when there's one above it?
We crossed it out, remember?
Oh, so then
Because that was unique for this column,
Yeah.
for this row and that column. So therefore that can't be unique.
Okay.
Used
so,
for this
so when it's
column.
crossed out, it's like it
Yeah.
just doesn't exist.
You can't use it anymore here. Okay? So let's allocate now. So let's see who teaches what. So Mr. Brown, Mrs. N, Mr. T who pities the fool, and Miss W. Okay, so Mr. Brown, what does he teach? Have a look and allocate the rock over there.
Nice.
Maths. What does Miss N teach?
Chemistry.
Chem?